Welcome back to CS1101. This is lecture 2, part 1. We're going to be going over identifiers, variables, and expressions. To begin, let's take a closer look at the print line method that we use to print things to the screen. So, as we've discussed, each instruction of code, each line of code in Java is referred to as a statement. And in Java syntax, we always end a statement with a semicolon. So when you call a method, in this case the method would be print line, and you put something in the parentheses of the method, the thing in parentheses is referred to as an argument. And as we go along, you'll see that there are some methods with only one argument, and there are some methods with multiple arguments. So here we have this entire line is one statement, and then print line is a method, and then the string, whatever you want to print, is the argument. If print line is a method, and whatever you want to print is an argument to that method, it leaves sort of the question of what is system.out? System.out is something referred to as an object, and specifically system.out is an object which is used for sending output to the screen. In this specific example, the argument to the print line method is a string. So let's take a closer look and talk about strings. A string is a sequence of characters. Oftentimes, we'll refer to this sequence of characters represented in code as a string literal, because you literally type the value into the code. So just as we saw in the previous slide when we were passing a string literal to the print line method, the string we wanted printed had to literally show up in the code, just as we intended it to show up on the screen. And so very much so in the same way, if you want to enter the word hello into code to save into a variable or print to the screen, you would have to start and end the literal with double quotation marks. The double quotation marks will not appear in the string. Those are used as special characters to denote that you are entering a string literal. There are ways to insert double quotation marks into a string should you want them to also be a part of the string literal itself, but we'll get to that later. So here are some examples of string literals that you could type into Java, and the Java would recognize as string values. So double quote, starting with a double quote there, HELLO, so, and then end with double quote. This would be a string literal, a valid string literal. And below that, this is a string 2, space, 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 space. It has extra spaces. So characters are not limited to only alphanumeric characters. Spaces are characters. In fact, in Java, the full Unicode array of characters are available to strings. So white spaces are represented in strings as well. So you can enter entire sentences, you can enter entire paragraphs into a string, just as long as you don't enter a carriage return. If you were to enter a carriage return, as you see in this particular instance, we have a double quote to start a string literal. We have characters, but then someone entered a carriage return. So what we have here is the compiler will recognize that a new line has occurred. It does not see a semicolon, and it also doesn't see the end quote to finish this string, and so it's going to flag this and say this is a syntax error. So a single string cannot span multiple lines. Strings can also not contain the double quote mark because the way this would be processed is begin string literal. We have characters, more characters, more characters, more characters. We hit a double quote. That would be considered the end of this string. Then we have the word valid, and then we have double quotation marks, characters, and then another double quotation marks. So a compiler would recognize this as one string and then a second string, and it would not understand what the word valid was meant to mean in this situation. So for this reason, we can't use double quotation marks inside of a string. There are ways to do that. We'll talk about that in a minute. However, you can use single quotes or apostrophe character in the string. So the bottom string would be considered grammatically correct in Java. However, if you did want to insert double quotation marks into a string, we would use what is called an escape sequence. An escape sequence is used to represent a special character which is not ordinarily legal or is not ordinarily capable of being represented. So examples of this, we said that we can't directly enter a double quotation mark because that would seem like either the beginning of a new string or the end of the current string. So therefore it can't actually be a character in the middle of a string. Instead, what you would have to do is you would enter backslash, and double quotation marks. Then that would be recognized, and when printed would show up as the double quotation marks character in the string. The similar thing, rather than pressing enter when you are wanting to insert a new line into a string, you can use the \n to represent a new line character. So when the string was printed to the terminal, there would be a carriage return appear where this new line character was entered. Similar with tab. So \t is a way of telling the string that you want a tab to appear when printed. And then \\, is a way to tell the string that you wish a backslash to appear where the double backslash occurred. So each escape sequence is treated as a single character when the string is processed. Let's go through an example so we can solidify what this really means and what this looks like. So we have our standard system.out object that we use to print to the screen, and we have our print line method, right, which is going to print whatever argument we give it and is going to print a carriage return after it. So let's look at these escape characters that we have. So we have a \\. So that would be an escape character plus a backslash. Then we have an escape sequence plus a backslash. Then we have an escape sequence and an n. Escape sequence for tab. The n is new line. We have escape sequence and double quotation marks. So it should insert double quotation marks when it sees that particular combination of characters. Again, double quotation marks. Then we have two backslashes and two backslashes, and then the string terminates. So we see the first double backslash show up as a backslash character. Then we have the word hello. Then we have this new line, which occurs, which brings the cursor down to the next line. Then we have this tab, which inserts space here. Then we have the word R. Then we have a space, which is just white space. Then we have an escape sequence for double quotation marks, which causes the double quotes to be printed. We have that occur again. And then we end with 4 backslashes. But each of these pairs of backslashes is interpreted and printed as a single character, 1 backslash, 2 backslash. And then because we used a print line, there was a carriage return, so our cursor now is on the next line below. So take a moment, look at this mini exercise, and see if you can write down what is going to be printed precisely, including carriage returns. So on what line each of these things would be written. Pause the video here for extra time to solve this before you move on to the solution. Okay, in the first statement here, we have our system.out object used for printing things to the screen. We have the printline method, which is a part of the system.out object. And we have given as argument this string literal. So we have a tab character, which is the \t. Then we have the character A, and we have the tab character, which is the \t, the letter B. Then we have the tab character and the letter C. So what this would print is tab A, tab B, tab C. Then on the next line, because we always expect a carriage return anytime we are using a print line. So in the next statement, we will pick up on the next line down. Again, we have our system.out object and our print line method, and we have the single backslash escape sequence and another single backslash escape sequence, and that is exactly what appears based on that. So then we would have another carriage return, but in the interest of space, we will just continue into the next orange box here. But we would have another print line. We have a print line, so we would have another carriage return. So on the next statement, again, system.out.println, and then we have a string literal, which only contains a single quote. Again, we don't need an escape sequence to represent a single quote. The single quote is a valid character in a string in Java. So single quote shows up and followed by a carriage return because of the print line. Next print line statement, we have a double quote, which starts the string, literal, and then we have an escape sequence for double quote, and an escape sequence for another double quote, yet another escape sequence for a double quote, and then we terminate the string with a double quote. So this is a valid string. It's a valid string literal, and we have 1, 2, 3 sets of double quotes that should appear in our output, and that is the case. Finally, we have print line statement with the string literal C colon, and then what we were trying to do is actually show the file location for not sorry.mp3. However, we probably made a little mistake here, because if you notice, even though this is exactly what we want it to say when it appears on the screen, the way that Java is going to interpret this is C colon, and then this is an escape sequence, so that's not going to show up as \t. And then you're using an escape sequence here as well, and this escape sequence is not going to show up as \n. This is going to create a new line. So what actually appears based on this output is C colon, and then a tab, and then odally, demi, and then new line, which causes a carriage return. Carriage return, is like pressing the enter button. And then sorry.mp3. So hopefully it's clear why this happens, because when in a string you encounter a backslash, that means that what's coming next is not to be interpreted as a normal character. It's to be interpreted as an escape sequence. So this combination of characters \t means tab, \n means new line, and that's why we get the output we have in this box. So now let's reverse the order. We went from having a print line statement and a string literal, and then attempting to understand what would be actually printed on the screen. Let's reverse that process and say we want to come up with a print line statement which would cause this output to appear on the screen precisely. So again, pause here to take a moment and attempt to write a print line statement to achieve this output. Okay, so let's look at the solution. So we have our system.out object, and we're using the print line method, and we have a string literal as an argument. So first of all, a / is a valid character. It's not special. So to get this /, we don't have to do anything unique. So this / is due to this /. However, we then have a \. Backslashes are always interpreted as the beginning of an escape sequence in a string in Java. So in order to get a \ to print, we can't actually enter simply a \ into the string, because it's going to attempt to look for an escape sequence, and when it doesn't see one, it's going to throw a syntax error. So instead, to get a single \, we have to use a double \. So the \ here says we're beginning an escape sequence, and the \ following tells it which escape sequence we want to use. And that causes a single \ to appear. Now, here we have two /. Again, /s aren't special, so we simply enter /. Notice we're also entering spaces. So there was a space in between the initial / and the following \. So we had to also enter a space as well into our string literal. Spaces are not special in a string. You can enter them directly, and they will appear just as you enter them. So we put a space in between the first two characters, and then we put a space in between our / literal and our double /. Now to achieve double /, we have to get one /, we need the / to start the escape sequence and the / to tell it we want the / escape sequence. And then we have to do another one. So hopefully this is beginning to make sense. Again, / aren't special. They show up directly, as do the spaces. To get 3 \, we have to have a total of 6 \. Escape sequence start, request \, escape sequence start, \, start, \. Then we terminate the string. So when this print line statement is evaluated and this string literal is given as argument, what will show up on the screen is precisely what was requested. Shifting gears from talking about strings, we're going to start here talking about identifiers. So an identifier is what we call the name of a string, class, or method. Now, their identifiers can also represent other things as well, but we're not going to worry about that. Let's just stick with classes, methods, and variables. So an identifier is different from a string. And a string is something that we have defined and talked about. It starts with a double quote and ends with a double quote. And there are certain ways to enter special characters, and those are intended to be able to be displayed on the screen using system.out or other methods. Identifiers are different from strings because identifiers are not intended to be printed to the screen as they are represented in the program. Rather, they are meant to be a name. And for that reason, we refer to them as identifiers. They are the way that a variable, class, or method is identified. So some rules here for how you can name something when creating an identifier. The first character can't be a digit. You can use digits, but it just can't start with a digit. They may not contain certain characters. So they can contain digits, they just can't start with digits, but they cannot contain at all a space, dot, asterisk, However, one of the good things about Java is that they do allow you to have identifiers be arbitrarily long. So for this reason, it's important that you give variables and classes and methods names that make sense. So don't name something class 1, class 2, class 3. That's not very informative. An identifier should be something that helps to document the program. So rather than having to always look at a comment to tell what a variable is, it'd be much more helpful to you for you to name the variable number of students with using a camel case capitalization to distinguish between each of the words. And we'll talk about what camel case is in a moment. But number of students is much more easy to read and understand in a program than variable 2. It's important that you make use of the fact that Java allows these arbitrarily long identifiers to better document your program by choosing appropriate names. These identifiers are case sensitive. So this is something that's a little bit unique to Java. Other languages are not like this. Some are, some aren't. It varies, but Java is case sensitive. So a variable named stuff, where it's all in lowercase, would not be considered the same variable as stuff with the S uppercase, which would not be considered the same variable as all caps stuff. Each of these would be considered separate identifiers. This is not true, as I said, in other languages, but it's true in Java. So each language comes with its own rules for how the grammar works. And one of Java's grammar rules is that identifiers are case sensitive. However, even though we've talked about there are certain special characters which you may not use in a identifier, and obviously you can't start an identifier with a number. There are those rules that we have in place. There are still other words, even though they don't necessarily break any of those grammatical rules, they're off limits. So that would include the word public as an example, because these are keywords, or also referred to as reserved words. They already have a special predefined meaning in the Java language. Other examples of keywords or reserved words which you're not allowed to use as identifiers: the word static, the word system with the S capitalized. You can't use that. Remember, Java is case sensitive. So lowercase system would not be considered the same as uppercase S system. Void would be considered off limits. That would be a reserved word. Class is a reserved word. There are many reserved words. And for a comprehensive list, refer to the supplemental textbook, the Regis textbook. An easy way to find out if you have used any reserved words is to compile your program, because if the program contains any reserved words used in any way as an identifier, then the compiler will throw a syntax error. We've discussed the rules of identifiers from a grammatical standpoint in Java, but it's also important to acknowledge and understand that there are style expectations for identifiers. So it's sort of like a dress code. Some companies may allow you to dress more casually. Others may say casual Friday. Others may say business attire only. This is similar to the expectations around identifier style. So, for instance, in the Python programming language, the style used for identifiers is quite different from that of Java. Similarly, if you were in a programming class in a different school or under a different professor, then the programming style requirements may be different. Where you work, the programming style and the identifier naming requirements and style expectations will be different, probably from what you learn or what you experience here in school. So style expectations are going to differ based on the context in which you're writing the code. In this class, style expectations are as follows for identifiers. When you're naming a class name, it should start with an uppercase letter. All right, and you should capitalize the beginning letter of each subsequent word. So it would be, this is what we refer to as camel case. So bake cookies with the first letter being capitalized. This would be the class name identifier style. For method names, they should begin with a lowercase letter and again be in camel case. So camel case because there's a hump in the middle of the word. So this is the method identifier style that we expect to see. And the reason for employing camel case is to allow for multi-word naming. Because obviously, as we said previously, identifiers are not allowed to include spaces. So there's basically two ways to do multi-word naming. That is to capitalize the first letter of each word, each subsequent word. The other is to include an underscore in between each word. And that is typically used in variables. Again, let me reiterate, identifiers should always be meaningful and descriptive. So notice how these identifiers, notice that these identifiers have more meaning than, say, class name 1, method name 1. Those sort of naming, that sort of naming for identifiers is not very informative. Bake cookies, hello world, string, those have meaning and they tell you something about the contents of the class. Student name tells you something about the content of the method, so forth. So make sure that you think about and choose identifiers that are meaningful and descriptive. In a program, it's often necessary to remember things. So perhaps we prompt a user for their age, as we did in a previous example, and the user enters their age. It's not very helpful if we don't somehow remember what they told us their age was. Other examples would be a name or a test score for students. If we were not talking about using computers and programming, then we could do this using some sort of sticky pad. We say, what is your age, what is your name, and we write that down. But how would we do that similar memory and retention in a computer program? As programmers, the way that we go about that is declaring a variable, and each variable must have an associated data type. The reason for this is a variable is going to be able to contain values which conform to the data type it is suitable to hold. So let's say that we needed to remember how much to pay the person that mows the lawn. Well, in ordinary life, perhaps you would write it down on a sticky note, lawn payment $50. In Java, if you wanted to remember that, in a program, you would declare a variable of type integer. You would choose an identifier name, which was meaningful. In this case, we would call it amount to pay using camel case. And we would assign it the value 50. Now, the 50 here, the way that we've written it, is non-arbitrary. We'll talk about this a little bit more, but notice it is an integer. There's no decimal point afterwards. So we said that the type of amount to pay was going to be an integer. So our data type was integer. So what we assigned to that variable had to be an integer value. So Java contains 4 primitive data types, one of which is the integer that we showed on the previous slide. In this case, understand primitive to being native. So Java natively supports 4 data types. So integer is the first, followed by floating point, character, and Boolean. So an integer can be represented in one of 4 ways. It can be represented in a byte, short, int, or long. The most common that you're going to encounter is int for integer. The others have specific use cases, and it's more or less exactly what it sounds like. A long is an extension of integer which is used in the situation where you have an excessively long integer. Short is where you know that it is going to be short. And byte is the smallest So long, short, byte, and int differ in the amount of memory which is required to hold the variable. Floating point. As we discussed on the previous slide when we were writing down how much to pay the mower, we wrote it down without any sort of decimal point because integers don't include decimal points. There's no fraction to them. If we needed to store a value which included a fraction, then we would need to use either a float or a double, both of which are types of floating points. The most common you're going to encounter is double. So literally what we're talking about here is the precision. So double precision is a higher precision floating point number. So this is a way to write down real numbers in this case being those which have fractional components. If you were going to write down a letter, so something that is to be interpreted as an alphanumeric character, then you would use a char. The last of the native data types is Boolean. A Boolean is often referred to as a bit. You can think of it as a bit in a computer. A bit is only able to take on the value 1 or 0. That's the same thing in this case. Boolean values are only able to take on true or false. True equating to 1 and false equating to 0. Some of you may be aware that in Java version 11, they allow the use of the keyword var to declare certain types of variables. In this class, this is not permitted. Do not use the var declaration. So as I noted on the previous slide, byte, short, int, and long differ by the amount of memory used to store the value. So each of them is storing an integer value. However, how much memory is allocated to be able to store the integer is what is changing. So if a variable is declared as a byte, then it only gets 1 byte of memory, even though the value is stored as an integer. So notice the amount of memory you have affects how large of a number you can actually store in it, which should make sense. So if you declare a variable as a byte, then the smallest number you can store in it is -128 and the largest is 127. This increments in short up to -32,768 to +32,767 and continues to increment in int and then very large in long. For this reason, integer is the most common declaration. It requires 4 bytes and it has very large storage. Typically, it'll do the trick. There are situations where you need something larger, and that's why long exists. And if you're trying to be more conservative in your use of memory, byte and short can be helpful. Similarly, a floating point number, which is of type float, only requires 4 bytes of storage, but also that comes with limitations on the size of number which can be stored. A double precision floating point number is twice as large, however it can also store significantly larger floating point numbers. So for this reason, you will typically use double precision floating point numbers simply because you run into fewer issues. Chars require 2 bytes because Unicode characters are encoded in 2 bytes, and the value can be any Unicode character. I said alphanumeric, but Unicode characters encompass much more than alphanumeric characters. All punctuation marks. See a list of Unicode characters for the exhaustive list of what can be encoded in a char. Boolean values, as I mentioned, are only able to store true or false, and they take up exactly 1 bit. So notice the correspondence between length of length of memory used, or the amount of memory used, and the size of the value which is able to be stored, those correspond and are directly related. Here are some examples of each type of primitive. So here are examples of integers, floating points. Characters, again, notice that it's not simply alphanumeric characters that are included in the Unicode set. The pound sign as well as the new line character are included in the Unicode set. To define a character, we do not use double quotes. That would define a string. To define a character, you enclose it in single quotes. And then Boolean values, true and false, are the only two values for Boolean variables. So Java also includes types which are not considered native or primitive. These are called object types. More about these object types later. A typical use of a variable is to store the value which is generated by an expression. The idea of an expression is quite broad. Any statement or operation which assigns or computes a value would be considered an expression. So a single literal, like a string literal or an integer literal, these would be expressions, but they can also be complex if they incorporate arithmetic operators and assignment operators. So some examples of this, if we were going to have a mathematic expression that involved operators, this is what you would expect to see, something of this nature. Increasing the complexity to involve parentheses so that you can affect the order of operation in the second statement, but then even something as simple as a direct integer literal shown in the bottom 42 would be considered an expression. So literals, arithmetic operations, anything that computes a value or assigns a value would be considered an expression. So again, variables often are used to store the result of an expression. Based on our definition of an expression, we said that literals would be considered expressions. So, a value as simple as 42 is an expression. If that's the case, then a arithmetic operation that uses operators such as 42 plus 2 would be the combination of two expressions, with 42 being the first expression and 2 being the second expression. So operators allow us to combine values, and each of those values are expressions. Typical operators in Java that you'll see are addition, subtraction, multiplication, division, and then this one is very useful and common in programming, but you may or may not have been exposed to it before, the modulus operation, which computes the remainder for a division operation. So when a program runs, the expressions in the program are evaluated. So as an example, the expression 1 plus 3 is evaluated to equate to the value 4, which is assigned to the variable x in the first example. In the second example, we have the system.out object and the printline method being used, and the argument to our printline method is the expression 3 times 4, with 3 and 4 being expressions in themselves. So the multiplication operation is combining two individual expressions into a single expression. And when the program runs, it evaluates to 12, which is what is passed as the argument to the printline method. One of the common complexities when programming using integer data types is remembering how math works when you're dealing with integers and knowing the rules of whatever programming language you're using. So, as a couple of examples here, if we were to divide 14 the integer 14 by the integer 4, okay, then the integer result is 3 with a remainder of 2. But since we're only allowed to return integer values because the expression is using integer data types, then the expression is going to evaluate to 3. So 14 divided by 4, that expression is going to yield an integer value of 3. Even though the precise value, if we were using floating point numbers, would be 3.5. Similarly, 47 divided by 10, so obviously 47 divided by 10 is 4.7. However, you cannot represent fractions in integers, so we don't round. So 47 divided by 10 is precisely 4.7. However, when we are using integers, so an integer for 47 and an integer for 10, then the integer expression evaluates to 4. It's not rounded. The fraction portion, the remainder, is simply truncated. So whatever would come after the decimal is just dropped. That's important because it would be an easy mistake to make to expect that 47 divided by 10 would be 4.7 and then you would round it to 5. However, that is incorrect. When you're doing integer division, whatever the remainder is, regardless how close it is to the next number up, it is always truncated. So a less intuitive example is 1425 divided by 27 is 52 with a remainder of 21. The remainder is dropped, and the integer division would result in 52. Further examples: 32 divided by 5, 84 divided by 10 is going to evaluate to precisely 8.4. The 0.4 fraction is going to be dropped, and the expression evaluates to 8. 156 divided by 100 is going to evaluate to 1. Dividing by 0 will cause a runtime error. We've talked about that previously, but be careful of that as well. It will compile, but when it runs, it will crash the program. So be aware of that. Dividing by 0 does not work. Similar to the integer division operator, we also have the modulo operator, which we talked about briefly before. So the modulo operator is actually used in situations where we want to compute the remainder. So in integer division, right, 14, the integer 14 divided by the integer 4 is going to result in the integer 3 with a remainder of 2. Now, if we were doing the division operation, we would simply drop the remainder and 3 would be returned as the result of the expression. However, when we're using the modulo operator, we drop the 3 and we return the remainder, which is 2. So another example would be 218, which is then divided by 5, resulting in 43 with a remainder of 3. We drop 43, and the result of the expression 218 modulo 5 is 3. Other examples would be, and this is how it would look in code. So in the way you read this statement is 14 mod 4 equals 2. Again, 218 mod 5 is 3. Take a second to think about where would this come in handy. When would you use this idea of modulo? Well, in general, modulo is useful anywhere that you have something that is periodic. A good example of something that's periodic would be a clock. Every 12 hours, a clock repeats back to the same number from which it started. So, in the example in the right-hand side, we have a clock which is currently at 9 o'clock. AM, PM doesn't matter. We're at 9 o'clock. What time will it be in 4 hours? So obviously we understand how clocks work. In 4 hours it'll be 1 o'clock. But how would you program that? Let's say that you were in a situation where you wanted to be able to take a starting time and then someone tell you how many hours had elapsed, and you would tell them what the new time was. So if you had a starting time of 9 o'clock and you stored it in the variable start, and we had an elapsed time of 4, and this is in hours, obviously. Notice that the variables start with lowercase letters. And we wanted to calculate the resulting time, or the new time. What would the formula be? It would be new, and we're using camel case, time equals start plus elapsed mod 12. Now notice here that these clocks that we're using are kind of unique because the hour returns to 0 at the top of the face of the clock. It's not 12. So how would it change? And this, I'll leave this as an exercise for each of you. How would it change if instead of this being 0, if this were 12? How would the formula used to calculate the resultant time change? And finally, here we have some other ways that modulo can be employed to do some useful things. For instance, figuring out even or odd. So if you want to know if a number is even, all you have to do is mod by 2. If the answer is 0, that means that 2 evenly divides into it, which means the remainder is 0, so therefore it is even. If the remainder is 1, that means that 2 does not evenly divide into it because it has a remainder of 1, and therefore it is odd. Obtaining the rightmost number, the rightmost digit or rightmost digits, either way, you can be done using modulo. If you consider that any number modded by 10 is going to return just the ones place, then that's a way of returning the rightmost digit in a decimal-based system, so a 10-based number system. Similarly, you can obtain the rightmost digits rather than just the rightmost digit using the modulo command. So if you want the rightmost 4 digits, then you mod by 10,000. If you want the rightmost 5 digits, you would mod by 100,000, so forth. And we already went over how it can be used to do clock math. In general, like I said, it can be extended to anything that's periodic. And if you notice, each of these are periodic in nature, and that's why modulo is helpful. Some weird examples of how modulo is employed. So if you were to do 8 mod 20, so you're saying 8 divided by 20, then the remainder is going to be 8. And so that's a little odd, maybe not so intuitive. So quickly I'm going to introduce a simple way to calculate a modulo command for simple expressions using small numbers that makes it easier to understand how negatives work when applying a modulo command. So imagine that we have a clock face that has only 3 numbers around it. So we have 0, 1, and 2. So this is our clock. And this is equivalent to modding by 3. So if you think about it, if we had the number 4 in this system, the number 4 would exist at 0, 1, 2, 3, 4. So 4 mod 3 would be equal to 1. We can easily just reverse the direction of the circle to figure out what negative 4 mod 3 would be. So we start at 0, and we go -1, -2, -3, -4. So -4 mod 3 equals 2. The result of a mod command involving negative numbers is often difficult to understand because mod always returns a positive value. So the general way to compute a modulo involving a negative number would be to do the division. So 3 into -4 is going to be -1. Then we're going to subtract a -3, which is going to result in a -1 remainder. But we have to return a positive value that is between 0 and 3. So the way to do this is -1 plus the value which we modded by. -1 plus 3 is going to equal 2. So that would be a mathematical way of going about this. So get the negative remainder and then add the value by which we modded.